My father is an engineer, so I think that's not necessarily uncommon for women that are in engineering, as they had some sort of a role model, so I certainly had that role model. I've always been good at math and science, so it seemed like a logical place. So I was interested in the environment back when I was in middle school. I was living in Japan at the time, going to an American school, and we had a week trip, field trip, with the class to a volcanic island and their tidal pools and things, so we got to really see and explore the environment, and that really got me excited about wanting to do something for the environment. My research is looking at the removal of organic compounds. Our focus has been pharmaceuticals and personal care products from water systems. With time, if discharges from an industry, we call them legacy compounds, there's something that's been discharged, decades ago, it stays in those sediments. So there's still concern in trying to remove those compounds from the environment that are stuck in those sediments. So this technology that I've been using in both of these projects is using ultrasound. So you may hear about ultrasound for imaging things. We use it in a very different way. When we send out a very much higher power wave than what's typically used for imaging, we create in a water system a bubble. It's called a cavitation bubble. So you pull the bubble and create the bubble, and then a pressure comes in and collapses this bubble. These bubbles, when they collapse, there's not enough time for heat transfer out from the bubble or mass transfer. So when that collapse happens, it heats. Temperatures inside bubbles have been measured and modeled by physicists and chemists to be a temperature similar to the surface of the sun. So we get chemical reaction from these bubbles that can treat and remove contaminants from these systems. So we're trying to explore how we can optimize the system, make it more cost effective, and make it viable. So trying to figure out what these compounds are, which is not the focus of my research, but how do we remove them? Do we need to remove them, and how much? And then how can we remove it is the things that we need to look at as environmental science and engineering researchers.